Hello, and welcome to today's episode of Rawkode Live. I'm your host, Rawkode. Now, before we begin, I just want to take a brief moment to say thank you to Equinix Metal. They are my employer, and they provide the time, resources for me to invest in this show, find great hosts, and find experts to come and share their knowledge with us so we can all learn together. If you want to check out Equinix Metal, please feel free to use the code Rawkode-live. This will get you $50 in credits. That's roughly around 100 hours if you spend it wisely, but go the fun route and spend it much quicker with larger machines. So today we are going to take a look at the Operator SDK, and I'm very fortunate to be joined by a colleague of mine, Dennis Kelly. Hello, Dennis. How are you?
I'm great. Thanks for having me today.
No, my pleasure, definitely. So you work for Equinix Metal too, which is fantastic. So,
yeah.
And you are a staff Kubernetes engineer. So you spend a great deal of your time working with Kubernetes. Do you want to give a quick introduction of yourself, and then we'll talk about the Operator SDK as well?
Absolutely. Deno Von Diesel is my Twitter handle, and you can find me there and ask questions later if you want. My nickname is Deno, but also go by Dennis. I work on our delivery engineering team here at Equinix Metal, and we stand up the Tinkerbell API that we use for provisioning on our Kubernetes clusters. I've actually only been here a few months, but already learning a ton and excited with the work I'm doing on the Operator SDK, and happy to share that today.
Awesome. I think we actually joined roughly around the same time, if I remember correctly.
Yeah.
We have our first comment already. So Hannah says, excited for this talk, and I think they possibly know you because they say, hey. So hi.
Yes. And I need to give a shout out to Hannah and correct everyone on the proper way to say Kate's, and that's Kubernoodles. So we'll be doing some Kubernoodling today.
Kubernoodles. I like it. I'm on board with that for sure. So can you tell us just in a summary, what is the Operator SDK?
Well, even to back up a little further, let's talk first
what is about Kubernetes.
Well, hopefully people understand what Kubernetes is, but the Kubernetes operator is just an extension of the Kubernetes API. When you think about interacting with a Kubernetes cluster using kubectl or kubectl, however you wish to pronounce it, you can then extend the Kubernetes API to do like custom automatic programmatic things and define custom resources within your Kubernetes cluster. And, it's very popular in kind of like the DevOpsy area that I work in because, there's things that you want to do like backups or, customized automated deployments. Say you want to create your own autoscaler. The Kubernetes operator provides a powerful platform to automate a lot of those tasks. And the Operator SDK, while it's available in Golang and what we'll feature today, you can also do this with Ansible and Helm and other platforms, but it's just a very powerful platform that kind of bootstraps your operator development environment and makes it easy for you to develop operators for your environment.
Okay, so what we're going to write an operator today, if I'm not mistaken. Is that correct?
Yes, we're going to do a very simple case. We're going to call this the add operator, where we basically take two add-ins and compute the sum. And while typically your operators are going to interact more so with objects and resources within the Kubernetes ecosystem, this will at least demonstrate how to get up and running with some simple business logic, but then we'll also wire in some useful tools that you would actually use for interacting with those other resources.
Okay. Will we be running today's operator inside of a Kubernetes cluster?
We sure will.
All right. I've always I've dabbled in this in the past and never really been terribly successful. And I think it's just always that development environment and how you work with it, how you get it in. So I'm looking forward to just seeing you kind of break all that down for us and
yeah, absolutely.
Learn a lot. So shall we get your screen up when we get started?
Yes. Yeah, let's go there. So here you see I have a Mac with a terminal open. Really, the only prerequisites to building this is having make installed and having Golang. And I'm using, I think it's 1.15, and then the Operator SDK. The latest version is 1.2, and that's what I have downloaded, and you can get that using Brew. And so when building an operator with Golang and the Operator SDK, you're going to want to start in a directory that's in your Go path. And so that's why I have this Go source, GitHub, Deno von Diesel. And I'm just going to make a directory here for our new operator. And we'll close this guy down for a minute. We've got some commands here. I'll copy and paste because I am not the best typer in the world. And so we're going to init this directory. We're just going to use the domain example.com, and that's basically the domain name for the schema that we're going to create. And I'll list me as the owner, dekelly@equinix.com. Here it's going to leverage the controller runtime and basically set up our directory with all this boilerplate code. And you can see we have a make file, a Docker file, a bin where it's already built our first manager with basically nothing inside of it. And the next thing it's going to want us to do is create our API.
Okay. Do you mind if I ask a few questions as we go?
No, please.
So, I've never done this before, so some of these questions will be hopefully just to clarify my own understanding. But the Operator SDK as a binary, as a command that you have installed, it's just for this boilerplate stuff, right? It doesn't really do anything else. Everything else is consumed, I'm guessing, by something in the Go mod that points to the Operator SDK.
Correct. So Operator SDK is just creating the directory structure for us and building our initial main.go, which is going to kind of be the manager that gets built. And the manager will then have controllers for the operator. And, and then when you want to say, apply a custom resource that is of this type, it'll go to the reconciler for the operator to do the business logic, compute everything, and return the results.
Okay, sweet. And that domain flag that you have passed, is that going to be like our prefix for our API version? Like, is that what separates it out from other controllers?
This one I have highlighted. So like the initial operator init that we just ran just sets up the directory structure. And then we're going to actually add the schema to our API with this next tab.
Okay, sorry, and you go.
Go ahead.
I just didn't understand the -- domain example.com in the previous command.
So like when you create a resource in Kubernetes, you're telling it it has this schema, and it's typically domain.com/v1 or whatever. And so that's all that's using that in the custom resource definition. And so it can be anything that you want it to be. Example.com is just kind of the default. But typically, if you're creating your own schema to extend Kubernetes, you would use your own domain name.
Okay, thanks.
And it'll make more sense here in a minute too. Because now we're creating this add operator, and we're just going to put it in a group called math, because say we want to do a subtraction or a multiplication operator later, we can still add it to this same project, or just have it part of that schema group. And so now we have kind of all the files that we need to start developing the operator. And we'll start here with the main entry point. And so you can see it's using the controller runtime to set up everything. And the nice thing about this is behind the scenes, it's creating the manager for the operator and adding in a lot of features that you'll want down the road, like automatic collection of metrics. You can do leader election if you want to, say, run multiple replicas. And then it's just wiring in our controller into the manager and then starting it up. And so there is one addition to the controller that I'd like to add is oftentimes with custom or with resources, you're going to want to add a recorder so that you can publish events. So say your operator is, building up a new application. It may take time for it to, download the image, deploy the container, and you can then, since it's asynchronous, you can publish these events so people can then check in on the kind of status of their resources being built. And so the manager already includes a record or has a recorder. So we're just going to add this to our reconciler right here. And so we're creating an event recorder for add. And, other things you could do is, here we have a logger that's set to use dev mode. You could say add another flag to your container startup that says, whether or not you want to use dev or production. And just have that be a Boolean, and then have that specified here when you set up your logging. And so the nice thing about it is it really, sets you up to really focus on your own business logic and your own APIs and controllers. And so since we created the API under V1 Beta 1, we then go into our add types. And this will be the schema for our operator. And I, again, kind of pre-built this before. And again, I'll just copy and paste, and you'll see it bigger here on this screen. And so again, this is kind of a template scaffolding file. Add spec is how we define the desired state of the operator. And so what we want to be able to do is take two add-ins and compute the sum. And so what we're going to submit to the API are those two add-ins. We're going to say they're integers. And then the next thing we do for the status is the observed state. And so when it's all said and done, we want to have that sum computed and available. Oh. And so, this really defines the API that we're building for this operator. We really don't have to do anything else with it, because our add spec and add status then become part of the add struct add list. And then the schema builder will register those two new schemas or custom resource definitions within the cluster.
Okay, so when we ran that last generate command, I noticed that I asked you two questions. Do you want to add a resource and add a controller? So that yes. Boilerplate is just an empty custom resource definition with a controller that's watching it, and then we have to then decide what goes in that spec, what goes in that status, and that's you're just adding that to the structs.
Yeah, and it's as easy as that. And so the last one it created was our controller. And again, kind of boilerplate code. And so it's setting up our reconciler and our logging for you. And so one thing that we did with our reconciler is we added in an event recorder. And so we're going to want to also add that to the definition of our controller here. and then demonstrate how to use that. And so the reconciler has within it your logging, the schema, and then it also includes a Kubernetes client so that we can then query to like either list, create, update objects within Kubernetes. And so what we're going to do here is I'm going to kind of bring in some more boilerplate. Because what we're going to want to do is when we receive one of these custom resources for the ad, we're going to pull in that as a what we call our instance. And so it's of type math v1 beta 1, and that ad struct that we created in our ad types over here. And so this ad struct is going to have metadata, the ad spec, the ad status, and that is the object that we're working with in Kubernetes. And we use our reconciler client to get that instance. And then we're just, kind of checking errors and also recording events based on those errors. So someone wouldn't have to necessarily go into log files to debug problems with their custom resource that they just created. They could just describe it and see, what error had occurred. And so if the error is that it's not found, we want to just return it and re-queue. But if we have a problem reading it, then we're going to retry reading that request. And so that's all we're doing here with the boilerplate. And then the next thing that we're going to do is just compute our sum and update the status. And so here the instance status sum is coming from the spec of our two edits. And then once we calculate that sum, we want to update that object in Kubernetes. And so here we're doing using our Kubernetes client again, the status update on that instance, because then it will publish the sum into that custom resource. And again, using logging to and event recording here to post errors. And I found the event recorder to be super helpful because that way operators can easily obtain information about the status of their custom resource without having to go to log files.
Yeah, I think it's one of my biggest frustrations when I'm working with Kubernetes is like the event log is just sitting there empty and I'm like, well, nothing's working, and I have to start hunting down every log from everything I can find.
Yeah. And so this function down here set up with manager, that is what gets called in our main Go routine to add this controller to the manager. And so we created the repository as, the add operator, but we could say change the name to math-operator and add additional controllers into this. So, and, having these as kind of your boilerplate files, we could copy it over and create, say, a subtraction spec and a subtraction controller.
Okay, so in your experience then, do you think it's better do you separate out all these reconcilers to be their own different controllers, or do you use one controller that kind of monitors multiple resources? Like, what is the best practice there?
I think it really depends on like the business and, as always, like the business and the situation. Like I like to think of the operator as a manager of controllers. And so sometimes there's different operations that you want to do from within like the same management organization. So if you're thinking about people, you're going to have a manager, and then you're going to have multiple operators working for that manager. And those operators, are going to have these reconcilers, like the procedures that it runs to do specific tasks. And so, based on the request that's going to define like the API. That's the request coming in. And then there's a procedure to run on those specific values. And so you can have multiple operators or controllers under one manager. And we're actually doing that with more extensive operators that we're using in production. And it just makes sense. You're deploying one pod, and they kind of share a lot of the same backend code in terms of other business logic that it's going to perform. But if they really don't share any code, it's fine also separating them out.
Okay, cool. Thanks.
And so, now that we've built the functionality to do everything, we're going to generate the configs for this, because we went in and updated our schema here. And so when you update the schema of your controller, you then need to recompute the custom resource definitions. And it's doing it from this code. So that way we don't have to build all of that YAML ourselves.
Is that what that weird comment syntax is with the pluses at the start? Is that a Golang thing, or is that just something the Operator SDK is parsing out of the code?
Yeah, that's the controller generator. It's taking a look at this add types and then generating the spec based on this Golang file.
Okay. See lines 37, 38, they look special. And it's not something that I've seen before in Go. I just wasn't sure if that's a Go thing. Is this just an operator cube builder thing? Like,
it's a operator. So it's using those as annotations.
All right. Okay.
And so we can now see, so we have our math.example.com ads. And based on the file that we created in Golang, it's created our custom resource definition that will get added to Kubernetes.
Wow, even that's all the open API stuff.
And then one thing I won't do live here is pushing or building the manager, our operator, and pushing that to a repository, because then I don't have the greatest internet and it would take a really long time. So I've already pushed this to a cluster, but I can show you what you would need to do to make that happen here as well. So what you're going to want to do is, add this custom resource to your cluster. So I'm just k-apply the config crd bases. And then you'll push the role in binding, because again, all of these are generated for you. So you'll apply that and then apply the role binding. And we're just going with the defaults right now, but you can go in and change the namespaces and the user that you want to use for all of this. And the config manager is actually what deploys the operator. And that's done after you do, because here in the make file, you can see all your options. And so like manager will actually build the operator for you. And then you can also do a Docker build, and that will put it in an actual container and then push it. And in our case, we're pushing it to a Quay backend. And so with this operator now deployed, we can create our custom resource. And so this is where that example.com comes in, because here our API version is math.example.com v1 beta 1. The type of the kind is add. We're giving it a name of 5+7. Hopefully I didn't screw anything up in the cluster. And then we can get.
Dun, dun, dun.
And we'll want to do -o YAML here. So you can see the spec had these two add-ins, 5 and 7, and we defined that in our add.types. We computed the sum and pushed it back to this custom resource.
Sweet.
And so, yeah, that's the very basic business logic. Oftentimes, you'll be submitting values to, say, pull a list of pods and then perform some action on those pods based on the output of what's currently running. And then your custom resource definition will keep that group of pods in this consistent state all the time. And
okay.
So able, yeah.
So I want to understand this. I'm going to just throw some complete newbie questions at you here. Like,
yeah.
The boilerplate that you've built, right? I mean, you only added like 5 lines of code to this
Yes.
project, right? And there's this magic reconcile function which is being called. Now, what triggers that reconcile to happen?
So basically, this reconciler is what we're doing is extending the Kubernetes API to support new schema. And so what triggers the reconciler is when we add this custom resource here. So this is the API version, and this is the kind. And because we uploaded that custom resource definition into the cluster, Kubernetes now recognizes this as a resource within the cluster. And so, and if you look, here's the self-link, APIs, math.example.com, v1, beta 1, namespace, system, adds, and then this is the name of our custom resource. And so basically, we're just creating a new resource in Kubernetes. Because by default, it supports, pods and secrets and, all the various resources within Kubernetes environment ecosystem. And we're extending that API to support this math operation.
Okay, so if you modify that file and change the 5 to 31 and apply it again, does that cause the reconcile to then rerun and update the status?
Yeah, we can keep the same name, so it'd still be the same resource, but we'll change this to a 7. And so here, it didn't say that we created 5+7, we configured 5+7. We're changing the state of it. And so then, even though the name of the resource is 5+7, we have a new sum.
Cool. And that's just all provided by the Operator SDK hooking up everything that we need. So you really, when you said you just need to write the business logic, like that's a pretty cool way of doing it.
No, I found this to be super powerful and cool because you basically get to dive right into your own business logic. And say you want to start scaling pods, you can get information about the pods based on the metadata that you provide it, and then we're at a certain load level. Let's say add 2 more pods and scale the app.
Okay, nice. I like it.
Yeah. And so, yeah, it has a lot of applications for software developers, DevOps, security, even testing, because you can, mock failure situations within an operator to, test your environment. So it's a really powerful platform for managing Kubernetes.
Yeah, definitely. I can see why a framework like this is so appealing. Just like 5 lines of code, and right away that thing's just running inside the cluster, monitoring custom resources, subscribing to events in the Kubernetes API, and then calling a reconcile function. I mean, there's a lot going on there under the hood. And
yeah, absolutely. And then, the deeper you get into it, you can go into this controller runtime and learn about all the other things a manager can provide or a controller can provide to extend it. And I showed one example of, say, adding that event recorder, because then when we didn't have any errors, but like when you, say, describe your resource, if I can type, we have no events posted, but say we ran into errors, all of those would be listed down here.
okay, can we trigger one of those?
Well, I wonder if I don't think I think that would be hard given the errors that we're checking for right now. But because the other thing too is it sets up a testing framework in this suite tests. And so with this simple example, we're not really checking for, say, integer overflows. And so maybe we pass 2 integers in that would then buffer overflow the integer that we're putting it into. We could check for that as, say, a test case, and then error on that so that we don't cause problems.
Okay. So what is the, sorry, is there something else you want to go on to before I just keep throwing stuff out?
Keep throwing away.
Yeah, so as a developer, right? I mean, I'm sold now that I want to use the Operator SDK if I'm going to build an operator. If I were to make a change to this code now, say we wanted to add a new event recorder just every time it's updated, and say, oh, we changed the value changed from this to this or whatever. What's my development experience like? How do I just go run and it runs in the cluster? Do I have to build the image? Do I need to use other tools like Scaffold or Tell? What is the kind of process?
So, we could say do a R recorder. We're going to post it to our, because we could also add events to other resources within, but we'll add it to our instance here, event type info.
You're going to have to get a Kubernetes in there somewhere too.
Yeah. And so if we, let me see if I can build this quick enough to have it add that functionality in. But basically, you would see in the, if you look at just a standard event from another resource, it would just say, for your instance, we called it 5+7 info type sum, and then computing sum on Kubernetes. And these are useful when you have business logic that's going to take a long time.
Yeah.
And so we just add that simple line, and then oh, I forgot to do my imports. But I can go back and add that real quick.
So I'll just share a link on the screen as well to that repository. So, feel free to.
I can make that public. Right now, I think it's internal to cool people at Equinix Metal, but I will. I'll talk to my boss. We can open that up. I don't see that as a problem. But yeah, then you would just make your image. So you would make your new image. You would then push it to your repository, and in our config, manager, this is where it gets deployed. And so if say you, with your Docker push, you don't use latest, you could then update this file here to specify the specific pin that you wanted to use. And then it's just kapply config manager.
I mean, I take it you're just using Docker for Mac here, right?
Yes.
Yeah. So, I mean, if you don't actually need to push that to a remote repository, if we add image pull policy, if not present to that, then it should just work with the inbuilt Docker for Mac one.
Yeah, I'm actually using one of our Kubernetes clusters that are in Metal to run this, so not on my Mac. That's why some of the results take a while to come back.
Right. Okay. So,
but here I do a Docker login to Quay, and then I push the image to this packet add operator. And then I've updated the config to use that Quay image. Okay. And so this is running on a fully functional Kubernetes cluster.
Right. Okay. That's why we're not building and pushing. Got it. That makes sense. So can we take a look at that struct as well that we defined for our CRD?
Yeah.
Because I'm thinking, in my head, what if we've got slightly more complex custom resources? Like, is there a way for us? Oh yeah, if I can see some sort of annotation stuff here, so maybe we can go over that. Like, what if I've got mandatory fields versus optional fields? Is there a way for me to kind of specify that?
I don't think I've gotten into that with my experience yet. But basically everything is required. So right now, and so if I modified our add YAML and I removed add N1, it's going to error on us. Oh. I cannot type.
That's the curse of people watching you. Your typing skills always go out the window.
Oh, it's not going to be required. But say I added something that wasn't here, like. That's so weird. I've never seen that yet. Of course, during demonstration.
Yeah, I think Kubernetes is just let's describe it. Let's see what 5+7 actually looks like in the cluster. Let's get, or do a dash o YAML, whichever one's going to show us more details.
Yeah.
But I guess Kubernetes. So I actually expected it to work when you removed one, because I seen an annotation in your struct that says omit empty, and that kind of seems to me like maybe an optional annotation. I'm not really sure. I'm guessing more than anything, but.
So it looks like it initialized add N1 to 0, even though it wasn't there, because we still have a sum of 7, and it didn't error out. And I think that has to do with you can specify annotations whether to be strict or not on your schema. And so I think it would be, from what I've worked with on operators thus far in the 2 months I've been working with them, I actually error out if we don't have the information we need. And then if it's optional, then you can default that value, or just continue on without it, depending on what the situation is.
Yeah, sweet. Cool. All right. If anyone's watching and has any questions, feel free to drop them in the chat and we'll tackle them before we finish up. I guess I can throw a few more at you just now while we wait. So let's pop open a reconcile function again and have a look in there.
Oh, sure.
I think I'm still kind of amazed at how little effort is actually required to kind of get something get something.
There's lots of magic going on.
Yeah. So
yeah, the only things we added was where put your logic here, and we return the result at the end. So
yeah, it's pretty cool. I like it.
Yeah.
So is there any? Sorry, Nico.
Like another example would be to go. You can grab stuff from say core v1, like secret, and then specify the name and namespace of that secret, and that you could then pull that in and manipulate it. Again, you can do our client get on pretty much any resource within the Kubernetes cluster. And typically that's what you're going to be doing: grabbing pods, grabbing secrets, defining deployments.
Yeah, definitely. I can. I mean, I guess we're kind of reaching a stage of, I don't know if it's Kubernetes lifecycle or whatever, but there's a bit of a proliferation of controllers. Like everybody seems to have a controller for almost anything now. And when you see something like this and you're walking through and showing us how to take advantage of the Operator SDK, you can kind of understand why. Like,
yeah,
because you get a lot from it. Like, by defining a couple of structs in Go, then you get all these custom resources that are available to your Kubernetes cluster. We can add the business logic to the reconcile function and just deploy it. And then we have our own ability to tweak the way that Kubernetes works to a certain degree.
And I'd also mention too that Operator pre 1.0 was kind of different, and I think a little harder to use, where that's why I focused on the 1.0 or 1.x series, because it already wires up all the metrics for you, generates even more of the, hides more of the boilerplate that you would have to have in your own files anyways. And there are a ton of examples, especially with Golang out there right now. And so, and again, with, hopefully improve documentation and, help the community with that to make this even more viable, because it's super easy to use and really nice to get up and running with once you understand the concepts.
Yeah, definitely. Cool. Thank you. Is there anything else you want to cover?
I think that's it. People can hit us up on Twitter after this, or on YouTube, and happy to talk about more operator stuff.
Yeah, definitely. Feel free to grab either of us on Twitter. I think we're both. I think it's safe to say that we both like talking about Kubernetes, or Kubernetes.
Yeah.
Sorry. Yeah, definitely. So, like the ad operator, let's talk about the why behind it. I'm assuming you built this as a demonstration and a training material so that other people can see how to get started with this. It's internal right now. Like, is it something that you're going to continue to add on with more examples? Like, what's your plan for the ad operator?
I think the first thing is to go back and put some open source licensing on this and make it a public repository. And then, work with the community to provide more examples. I might just call it like the math operator. That way we can add other controllers in there to show how you would wire up multiple controllers under one manager, demonstrate how you use Go, which is the testing framework, and check more of those edge cases, like say we're going to overflow an integer. How do we want to handle some of those edge cases so that it's like a kind of a secure example, and then maybe some more examples of how you would interact with the Kubernetes ecosystem, like listing, retrieving objects, updating them based on it. And that might be just become another operator if we say move outside of the math concepts.
Yeah, I think based on what you're showing me, I think with my limited programming skills, even I could probably add like a subtract controller to this. I mean, I think I can maybe handle those 5 lines of code. I'm not sure, but at least I've got you.
No, I think you should actually that should be your next task.
Exactly, right? I should just be like, hey, let's add the subtract one. Because I could just
Yeah.
add the types and then the reconciler and then like boop, 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 and it's just the way it goes. So
Yeah.
maybe I will do that for a bit of fun.
Yeah, it's super easy. Send me the PR.
All right. Okay, so we just got a couple of comments there. So great ad pun and good vibes. Be cool if the emoji showed up, but it doesn't. But
yeah.
Anyway. All right, that was really useful. Really nice introduction to the Operator SDK. I'm hoping we can open source this as a bit of a fun experiment and encourage people to come along and add new types, and just I think it's it could be a really cool and fun educational resource for anyone that wants to go down this path. So
great playground.
Yeah, for sure. All right. Well, thank you very much, Dennis, for taking time out of your day to join me today and for putting that together and walking us through it. It was really useful.
My pleasure. Thanks for having me again.
And we'll try and maybe organize a part 2 then once we get this open sourced and see what we can do.
Absolutely. Sounds good.
Right. Sweet. Thank you. Have a great day, and I'll
Cheers. Well.
Thanks. Bye.